We'll also be looking at simple interest. For example, we could say the simple interest is 10% per annum, or it could be compound interest at 10% per annum. When we do these calculations, you'll see the difference between simple and compound interest. We'll start with depreciation in real life. So remember we said that simple depreciation is due to age, right? The value of the car decreased by 10% of its value each year. Or it could be, as we said, compound interest. All right? So some words that we might meet and need to understand. We know that money is used to represent the value of goods or services. And interest is the amount it costs us to use money. And a percent is the amount we borrow. It's a percent of the amount we borrow to be paid back along with the principal. So if you borrow some money, you'll have to pay back that money and also pay back the loan. When you borrow from your friends, usually there's nothing added. You just pay back the amount you borrowed. However, if you borrow from a business, for example, like a bank loan, you will have to pay some money on that. That's called the interest. Or if you deposit your money in a bank for savings, then you can also earn money on that, and that would be interest as well. So let's talk about simple interest. We talk about interest generally. Simple interest. It's a fixed percentage of the principal that is then added to the loan or to your savings. And the principal, we mean the money used for the loan. So if you borrow money, then that would be the principal. Or if you put money in the bank, that is also the principal. There's a formula for simple interest. It is principal times rate times time, and because the rate is a percentage, then that will have a denominator of 100. So the principal is the amount you borrowed, the rate is a percentage, and the time must be in years. So let us look at a question. Simple interest is the stage 3 question. Calculate the simple interest on $4,000 loan for 2 years at 8% simple interest. We'll try and do this on the board. Remember that per annum means per year. So it is $4,000, and the formula is the interest. Simple interest is equal to principal times rate times time divided by 100. So the principal in this case is $4,000 times the rate, they said, is 8%, and the time is 2 years, all over 100. We'll do the calculations together. Cancel by 100. So we now have 40 times 8 times 2. We could do 40 times 8, then times 2. 40 times 8, I could do that in my head. 4 8's 32, so 40 times 8 would be 320. So I now have 320 times 2, which gives me 640. Or I could do it on paper. So let's do it as if we're doing it on paper. So it is 40 times 8, 0, 4 8's 32. And then I'm going to multiply by the 2 times 2. 2 times 0, 0, 2 2's 4, 2 3's 6. Same answer. Okay? The interest on a loan or savings is calculated based on both the starting principal and the interest from previous year. So that's what compound interest is. So we have a question. A man invested $10,000 in a savings account. The bank pays interest into the account at the end of each year. The compound interest rate is 3%. The man does not take any of the money out. What is the balance after the bank has paid the interest? Now remember that the interest is the amount invested in the second year, right? The increase is the amount invested in the second year. So you will get some money in the first year, at the end of the first year, and then that will be used as a principal for the next year. So at the start, he has $10,000. The interest in the first year is 3% of the investment, and the interest in the second year would be 3% of the new money. All right? So the balance after 2 years would be the investment the balance would be the investment plus the interest in the first year, added to that the interest in the second year, and we'll get the total. So let us try and work on this question. All right? So let's start with the investment. So we're doing compound interest. So the investment, I'm going to call it investment, just INV. The investment is $10,000. All right? In the first year, he would get an interest of, at the rate of 3%. So that would be over 100. Canceling 100. We'll cancel the top as well. What's your answer? Is that correct? Yes. Cancel by 100. So in the first year, he would get $3,000. What would be his investment in year 2? His investment in year 2 would be a little more. So it would be the 10,000 plus the interest. So he now has $10,300. Do you agree with that? So with the compound interest, the principal in the second year would be the increase, would increase by the interest that he got. So let's calculate the interest in the second year would be the principal, yes, 10,300 now, times the rate of 3%. Let's cancel by 10, by 100, and we're also canceling by 100 again. What's your answer? 103? Very good. So the numerator is now, let me clean that up a bit. The numerator would be 103 multiplied by 3, which would be 309. All right, so let's go back to the screen and look at what we have. So the investment is 10,000. The interest in the first year, 300. Interest in the second year, 309. You total that, you can see that his total is new balance after 2 years would be $10,600. Sorry, 10,000, let's go back. That's $10,609. Is that calculation correct? Interest in the first year, interest in the second year, very good. All right, let's move on. All right, here's another example of, we're moving on now to depreciation. So we have looked at simple interest, compound interest. We are now moving on to depreciation. Now, depreciation is decrease in value over time due to usage, right? So here we have a machine. It has a principal cost of $110,000, and the simple depreciation is 20%. What is the value of the machine after 2 years? Simple depreciation is similar to simple interest, except that you are reducing the cost. So we're going to reduce the cost of this machine because of its age. So we're now doing depreciation, which means we are reducing. So we're starting with $110,000, and the rate is 20%. We could cancel and then reduce until we get the answer. But let us look at this question from a different approach. Suppose we said that if the cost of the machine depreciated by 20%, then therefore its new price would be 80%. We could also approach it like that. So I'm going to try that. I'm going to do that first, and then I will compare it with that. So it's $110,000 80%. How did I get the 80%? It is 20% less than it cost before, than the value before. Divide by 100, divide this by 100. So that answer is $88,000. Now in the second year, the same thing would happen again, but our new cost is now $88,000. So this is year 1, year 2. So that would be $88,000. 80% of that. How did I get my 80% again? Correct. We got our 80% because the cost was reduced by 20%. 80% is left. Cancel. And we'll get our cost. So I'm going to do that calculation now. So it is 88,000 times 80. Okay. 0 as placeholder, I'm multiplying by the 80, which is 810. So I hold my 0 place. 8 times 0, 0. 8 8s, 64, carry 6. 8 8, 64, 64 and 6 is 72. Is that correct? Okay. So then it means that in the first year, the cost of the machine is that, and in the second year, the cost is that. Or I could have done the 20%, then take it away from the $110,000. A little bit more difficult to do. The main thing to notice is that I have to do it year by year because the cost in the second year is different from the cost in the first year. So let's go back to the screen and see what we have. All right, so each year the value is 20% less. Oh, this was supposed to be simple depreciation. I just did compound depreciation. So let me jump over this and go to the next one. This one. That's what I just did, sorry. Compound depreciation. Okay? So the value is 20% less the principal cost in the first year, and then 20% less the new cost in the second year. Okay? 80% of full cost. So that's what I did on the board just now. 80% would give me $88,000, and then I repeat to get $70,400. Let us go back and look at the simple depreciation. So this is compound depreciation. Compound means that you take off the cost and come up with the new cost. So let's go back and look at the simple one. With the simple one, in year 1, it's 20% less of the principal. In year 2, it's also 20% less of the principal. So in all, it's 40% less of the principal. Therefore, the new value is 60% of the cost. Let's go again. It is simple, not compound. Simple, so in year 1, 20% less of the principal. Year 2, also another 20%. So that's 40% less in all, which means I'm left with 60% of the cost. 60% of the cost give me $96,000. Compare this with the compound interest. With the compound interest, the money is reduced faster. It's the same numbers, similar numbers, but we can see that it is moving faster. All right? So the answer is there. And this is a sample question from stage 3. All right? We looked at this one already. No, we haven't. Let's look at this one. The machine has a principal cost of $90,000 and simple depreciation is applied at 15%. What is the value of the machine after 2 years? Simple depreciation. Simple meaning 15% each year. So that's 30% in all. So therefore, 70% of the value is left. What's the answer? Okay, $63,000. There's a question I'd like us to look at. So let us move along. All right, let's look at this question. In a sale, a bed originally priced at $30,000 was reduced by 20% at the end of the first week, and then a further 10% by the end of the second week. So it's 20% in the first week and 10% in the second week. This is not the same as if you did 30% in all, because it was reduced first and then further reduced.